Okay, so today your goal is to conduct another investigation. It's the last one we'll do for Newton's second law. And again, just as a reminder, Newton's second law is this equation: acceleration is net force divided by mass. Yesterday you all looked at the relationship between acceleration and net force specifically. Today we're looking at the relationship between acceleration and mass. And again, since I think analogies can sometimes be helpful, acceleration is a change in speed, or we can think about that as a change in bigger ways too. And mass might be like a number of people, or maybe the power those people wield. And this is what we would call an inverse relationship. Um, and we're really looking at sort of what it means for two things to be inversely related, like what it means when I say mass and acceleration are inversely related to each other. So we're going to be using this simulation again. So you have another table for today's investigation, but this one looks a little bit different. Even though we've got all of the same stuff in our table, we've still got mass, these three different forces: applied, friction, and net force, and then an acceleration that we're ultimately looking for. So I'm in the same part of this simulation. As a reminder, when you first get in, it'll have you in net force, but we want to be in this acceleration part of it. So I'm going to come in here. I'm going to click all of these boxes on the right side. Again, we don't really need speed, but just for completeness, I'll click them all. And then I'm going to leave this friction slider right where it is. And the first mass that we're going to be using is this 50 kilogram mass. I'm going to pause this just so that things don't start moving on me yet. And I want to exert 194 newtons on them every time. And then I would want to make sure that I record this friction force, the net force. Again, this green arrow or this green vector is what shows us our net force, and then I would want to record the acceleration here. Now, instead of using the same mass like you did in yesterday's investigation, we're going to be exerting the exact same applied force to three differently massed objects. So for the 100-gram mass, you could do this a couple different ways. The easier way is to just use this bucket of water, but you can stack objects in this. So if you wanted to, you could just add it up so that we have these 250 kilogram boxes instead of a 100 kilogram bucket of water. And then for the 200 kilogram mass, I think this is the only way that we can do this, unless you stack all three of these together. But this fridge is a 200 kilogram fridge, and so you would just go ahead and apply the exact same 194 Newton mass to that fridge. And then for each of those different objects, you would just record those three forces. And then the way to, of course, figure out sort of like what that trend is showing, or what trend we're really getting at. You're going to graph mass versus acceleration, or progress in some way against sort of number of people, or power of the people trying to be convinced. And then the ultimate last thing that you're trying to do is sort of just, again, like you did for the relationship between net force and acceleration, think about how you would explain like acceleration and mass to like a young child, a younger sibling, cousin, anyone in your life, but sort of put that relationship in the simplest terms you possibly could to make sure that you really have a good grasp on these really important topics that we talked about for a long time in the beginning of the